Listen-only mode.
Good morning. I'm Faith Younghands, Project Manager at FIATech, and on behalf of all of us at FIATech, I'd like to thank you for joining us today for the ISO 15926 Information Models and Proteus Mappings, or IIMM, project webinar. We have an exciting hour set aside today to learn from Adrian Laud about this new FIATech project that is progressing the deployment of ISO 15926 and is open to FIATech members. But before we get started, let's talk about how to use the webinar system to maximize the use of your system today. So if you would like to minimize this control panel that you see, there's a little orange arrow on the top. So if you click on that arrow, it'll hide it, or if you want to click on it again, it'll open it. And since we have a large number of attendees on the call today, you're automatically put on mute. So if you do have a question, if you see down below in your control panel, there's a little box with the plus that says questions, and you can click on that and you can type in and send us a question anytime during the presentation, and we'll go over the questions at the end. And we are recording this webinar, and so it will be posted on the fiatech.org site. So if any of your colleagues, or if you'd like to forward it to somebody, they can link and watch it later. And lastly, before I introduce today's speaker, I'd like to remind all of you that FIATech is a member-based organization that brings together companies to accelerate the deployment of technology like ISO 15926 for capital projects. We have over 65 member companies and are always looking for new ones to join our growing consortium. And if you're interested in joining or would like more information about this project, please drop me a note at faith@fiatech.org. And now I'd like to welcome and introduce Adrian Laud, who is the Managing Director of Noumenon Consulting. Adrian has been involved with information integration for around 30 years, and he's been a consultant to a large number of the application vendors and as well as the EPCs and owner-operators. And he's been involved in STEP from the early days, and he considers mapping to be the key to information integration. In 1997, he saw ISO 15926 as a way to deliver practical solutions for integration. And XM Plant is the technology that was developed by Noumenon Consulting to realize this concept of ISO 15926, which is now deployed around the world. And Adrian has also, since August 2007, been a champion for the FIATech Roadmap, which is for Element 9, which is on information management. And I think you're going to enjoy hearing about it today. Adrian?
Okay. Well, let me just give you a little bit of background, which many of you will be familiar with, but the business drivers for why we need interoperability is the cost of handover, which was the prime driver for STEP being initiated, and the key parts there, time for startup of the plant and the regulatory requirements. And a study by NIST in 2004 put the cost of not having interoperability in the US alone at $15.4 billion per year. And the cost of unplanned shutdowns or explosions at $2.3 billion a year. The other key factor here is that the lifetime of a plant is 60 to 100 years, depending on the type, whereas that of a design system is, if you're generous, probably about 6 years, but they do last longer. However, it does mean that you're going to be going through many different design systems in the lifetime of the plant. And therefore, your information needs to be extracted from those systems. The other aspect is projects are global, and they're now with very many different systems. And this diagram, which I've taken from the DEXP presentation, actually shows some of the complications of those. Very complex, many handovers, and many different communication paths. To put it into the asset life cycle, then we talk about having the handover. In fact, there are several handovers and the key ones being shown here because the systems for functional requirements, functional design, asset specification and operation are all different. So you've actually got handover in each of those different areas. So if we put it in another way, I'd like to think of it as this pyramid where you're going from the concept through to the end of life and decommissioning, and the management of that information. So along the bottom you have all of the inline operations that are doing the detail work, and then you've got your decision support systems and the project management to ERP on both sides for engineering operations. So right in the middle we need this interoperability framework, the core of which is ISO 15926, with the objective to enable seamless access to information under managed conditions, so we know we've got the correct piece of information, by the right people, at the right time, for the right purpose. In fact, of those unplanned shutdowns, nearly all of them are caused by somebody picking up the wrong version of a piece of information and making a decision on that basis. So, very important. Okay, just a little bit of background with 15926. It's actually been anywhere 20, 25 years, and say it's 15, depending upon where you want to give the actual point of impact. There's a background project which led to it called Epistle, which came out of the STEP initiative, and the STEP initiative was in the 80s. So it's very difficult to pin down exactly where it came from. But the key to it is its flexibility, so that it can actually handle any information. But the focal point of importance is the reference data library, so that we are all calling the same thing. We have to use a same term across the world for all of the projects. So the RDL itself, the reference data library, contains the terms, which is the definition of what we mean by an apple or a pump. The template definitions, which are the structures of the key terms, and template information patterns, which are really assemblies of templates. The JORD project is a joint FIATEC and PCA project whose aim is to develop the reference data system that will then become a sustainable self-funding service for the reference data library hosted by PCA. I did find that slide, Faith. So 15926 is made up of very many parts, and there are few easy introductions to it, but there are becoming more and more help for in that. But the basic part, as I've been saying, is that we want to be able to communicate easily over the internet, and everything is focused by referencing the same classes and templates that are in the reference data library, so we know what we're talking about. We have a common set of terms, so that irrespective of what the actual system we're using in any given organization, then the information can be transformed into that common language, common form that we can communicate. So just briefly on a couple of key projects here, we identified that there were two key areas that we needed to focus on. Firstly, the ability to handle the business use cases, so that 15926 would be able to deliver the business requirements, and the technology to handle what was then evolving as the template definitions of Part 7 and Part 8, the actual RDF OWL representation. So the two projects that were involved there were Proteus, which focused on the business requirements, and Camelot, which focused on the technology for Part 7 and Part 8. Both gave successful demonstrations at the FIATEC conference in April 2009. And this was just showing that there are two aspects to the 15926 which have now been significantly brought on since that date. And what we're looking for now is to harmonize those methodologies so that we cover the scope for the information models for intelligent PNIDs and intelligent 3D models. And also to ensure the interoperability between the schema methodology that was used by the Proteus project and the template deployments that were used by Camelot and now the iRing tools deployments in the iRing user group, and also going to be where the definitions are in the IIMM. We'll also be updating the model documentation that was created in the Proteus project that is really the best way and the simplest way that newcomers can understand what the model actually is, and again, but focusing on the flexibility. So I'm not going to go through these, but these are just some key areas that are along the life cycle for downstream use, and as well as management of the information, visualization of the information, and exchange of the information, and also additional tools such as model comparison, which can then be done between dissimilar systems. So PNIDs from two different systems, or a PNID in a 3D model from different systems. Or indeed to use the topology that is in a PNID as the driver for the layout for the 3D. So these are all instances where having that neutral model is a tremendous business value. So the scope here is PNID and the 3D model, but the full engineering model. And in this context, actually, the PNID is a document that is used throughout the life cycle and is actually significantly more complex than the 3D model. So we'll cover the schema elements and the template definitions. We'll be also looking at the gaps, the gap analysis, so that we can understand what the missing elements are within the existing model based on the information that we're gathering from recent projects. The geometry will include the necessary objects for 2D graphics and 3D geometry required for PNID and process plan. These are part 3 of ISO 15926, and this is we'll be using just a subset of that information. Another key part here is that we will be developing the definition for symbols, both and components for 3D, but for PNID it's the symbol libraries, how those are actually represented, the definition of the content, and also the links between the geometric representation and the business objects that they are representing. And for PNIDs, of course, we have to cover the annotation and presentation so that the PNID that results from visualizing the 15926 model looks the same as it, or as the same as it can do, very similar and recognizable in an engineering context as to what that representation is. So for a given line font, for example, is the definition for visualization for an engineer for a given type of signal line, for example. So the deliverables will then be the updated documentation for the models. And I should also say here as well that these two are not completely separate models. The PNID and 3D model is very much the same. All the topology is the same, the structure is the same. It's just there are subtle differences between PNIDs and 3D, like their annotation is not really relevant to 3D, and you're not necessarily too interested in gaskets and elbows in a PNID. So the new classes that will be required to fulfill the requirements of this review will then be added into the PCA RDF sandbox. And those will include the definitions, the additional definitions that come from both previous projects and the new projects that we've been relating to. The Proteus schema, which was released as version 3.3.3, which has been in use, will be updated, and the enhancements that are required to meet the additional business requirements will be added into that schema. And a key part of this project, as the name implies, is to define the mapping between the schema elements and the templates. And to make life a little bit easier, we will be creating some examples of the XML and the corresponding Part 8 RDFL files. So one of the key points here is say that the information model is the same, and it's the same for a PNID as it is for a 3D model, and it is the concept. The definition can be in many different ways, and the representation can be in many different ways. So the key of this project is to make sure that we harmonize those methodologies, harmonize those using the JORD methodologies document. So 15926 goal is interoperability. We've said to remove the ambiguity by having a defined set of terms and a defined set of basic structures. It is designed for both information sharing and exchange, although it's principally used today for exchange. And the key is the flexibility. There are no fixed formats. There is no thing of saying, tell me what I need to add to define a pump. That's just not there, as those definitions are built up as needed using templates, the building blocks for ISO 15926. And again, how that information is transported is not relevant. It can be the conventional XML, it can be in a spreadsheet, it can even be in a Word document, but the two key ones that we're dealing with in this project are going to be the schema XML and the Part 8 RDFL. We have been proving this model for many years, deploying using the Proteus schema and a conventional XML. And some of the other projects that are more recent projects have been focused on deploying Part 8. So just to give you the overview here, we said we can actually define the model for the classes and templates in different ways. And the payload can be in different forms, in several different forms. So it's implementation choice. But the information model, the information that you're carrying, is the same. So if we look at the evolutionary stack, the absolute base backbone of everything is the reference data library. And this is where I want a single global access point for the classes and the templates and the template information patterns that are being defined. So templates, as they can be expressed using many different methods, and we can add to that using the use of our RDF enables standard web technologies to be used to additionally access that information and smooth its transfer. And the definitions here will all be put back into the reference data library. The end goal, of course, is knowledge management. That is some way away. We are in this where we're gaining significant business benefit, even just in this basic point here. Part 8 comes up to here. So in a diagrammatic form, what we have here now is effectively the document that is saying what the information model is for 15926 for the P&ID in 3D. That does not limit the model's use within the design space. It just means that is the scope of the information that we are interested in, or we are defining here. And the definition of that model will then be put into the sandboxes of the PCA RDS. Some are in the IIP and some are in the Proteus sandboxes. Those classes and templates can then be used to drive the Part 8 payload transfer. And the schema can be the mapping definition that we talked about between the classes and templates in the sandbox and the schema, and ensure that the XML that conforms to that schema is equivalent information content to what is in the Part 8 template payload of RDF-OWL. So these are just two of the options. There are other options, of course, because it's really that flexibility. This is the diagram that gives you a good overview of the scope. So activities, well, and we are defining additional classes, templates, and template patterns, and putting those back into the RDL. Proteus schema will be revised for those enhancements we talked about, updating the documentation and the mapping. We'll be taking the lessons from commercial deployments, which is obviously the best way to get feedback as to whether the actual definitions that we've got for the model are adequate to support the business needs. Other key projects are the OGI and XP project, which again are looking at real pilot pilot projects that are using models that represent the real data. And so with all of that feedback, we can update the model definition to fill the gaps as we see them, as we find them. Model instances, they can be either the schema-based XML, which is currently used on many projects, or the Part 8 RDF-OWL. Both implementations will coexist, and interoperability between those two can also happen. And the key here is that the information content is the same. So looking at this project and its relationship with others, then some of the key ones which I'll briefly go into are the DEXP group in Germany, the HEED project, IIP, the OGI, and there are others. And we're also looking for input from commercial projects which can give us the feedback. And certainly we believe that the deliverables from this project will be of assistance to those other projects, because what we'll be doing is taking some of their requirements to ensure that the model being defined in this project meets those requirements. So, just to give you a brief overview here, the Proteus schema is deployed on over 100 commercial projects out there, and that has been using the Proteus schema version 3.3.3 and dealing with fully intelligent P&IDs with full structure, graphics and annotation, and fully intelligent models for all disciplines. Part 8 deployments are focused on certain business cases, and initially they've concentrated on lists of attributes and the basic structure for P&ID. And as we develop the templates in this project, then a broader scope will be possible with the Part 8 deployment. And pilot projects that I will be discussed briefly in a few moments use both the schema-based and Part 8 deployments. So with Proteus, this has been used on any real projects, and the interfaces to using that schema are supported by the major system vendors for process plant design systems. And this really is proving that the model works for the business requirements. And those projects have come back, they've identified new classes and requirement for template definitions that are being absorbed by this project and will be added into the reference data library through the sandboxes. And this is just a brief summary of some of the projects here, both owner-operators and EPCs, and across the world. And just to give you an overview, we're not talking about small amounts of data or sample data sets. These are real projects with real size models, and where it doesn't quite do this is not an option. You have to find a way, so the model has to be extended. And of those, very few have actually given back any detailed analysis, but one for Woodside was a report was generated by Deloitte to say their return on investment is basically approximately 7 million a year, and most of that is coming from streamlining of the data handover, reducing the number of systems and therefore the actual training costs that they're using on their projects. And so return on investment after 10 years, I reckon, is going to be 84%. It's a rather accurate number, and we shall see what happens later. So of the pilot projects, we've got the DXP, which is Data Exchange in the Process Industry, part of the DECMA group. And their initial focus is on P&ID, using both the Proteus schema XML and Part 8. They've had demonstrations in 2012 with a target for P&ID interoperability by 2015. OGI has been giving live demonstrations since September 2012, again focused on P&ID and again using both schema XML and Part 8 RDFL. So the roadmap for DXP is looks like this. It started in 2011 and said, their aim is to have interface software available from vendors so that they can have interoperability for P&ID by 2015, and then they will move on to 3D exchange. So what they're looking at here is equipment and sets of equipment data, and these are just showing the stages here because the scope for a P&ID, especially the graphics, is not yet available, but not too far away, and all of the annotation. Then they see that the Proteus XMPlant schema is what is being used today, and as Part 7, Part 8 becomes available, they can use that as well. So the P&ID exchange, this is the brief thing of what was used by the vendors that were involved. You can see there are actually 5 vendors involved with 4 or 5 companies moving information about equipment for a P&ID between all of the systems supported by these vendors. The Mimosa OGI project, again, is looking for the full structure, and with a P&ID that was created in the same way as it would be for a real project, but as an example to incorporate all of the different types of data that could be expressed. So they're using, again, all of the classes and ontology from the PCA RDS reference data library, and the transport is either the XML or Part 8. And in the O&M side, then they're using CCCOM, which is another standard for operations and maintenance. And they've developed a transform engine to map from ISO 15926 to CCOM. And as I say, live demonstrations were September at ISA 2012, and they've been moving on with other demonstrations and presentations since then. So this is what they're looking to do. We have this, the gap between the engineering side and the ops and maintenance side, and that's where the transform engine occurs to take the information from ISO 15926 into the operations and maintenance context. And the pilot architecture has been with Aviva Bentley and Intergraph, and out of those, Bentley were using the Part 8 OWL RDF, and the other 2 were using the Proteus XMPlant schema, and at Aviva were using a subset of the schema, so mine specifically focused on P&ID with a additional validation within there. So this is the main engine, and we will be ensuring that all of these are totally compatible through the IIM project. Other projects that are linked directly in have influence as the PCA Fiatech Jord project and that of the geometry SIG. In the IIMM project, we are focused on the business objects, the structure, P&ID, and 3D, and the geometry SIG is focused on defining the templates required to support the geometry that is required for process plan. IIP are developing the tips. So if we go looking at here, the JORD project, the objective of that project is to create the commercially viable operation that will have a sustainable service that companies can use and can rely on to maintain that information and that reference data system. So where we are at the moment is that the RDS has been online since the middle of 2012, and sandboxes have been operational since early this year. We have created sandboxes for both the geometry SIG and the Proteus project, which is the IIMM. And we are already populating these with the definitions of the additional classes and shortly some of the, indeed some of the templates. There have been a number of documents published how to use the services of the RDS, and they're on the PCA website. So the geometry SIG, defining the Part 3 objects required for the 2D graphics for the PNID and the 3D objects for process plant models. And those definitions will be loaded into the PCA RDS sandboxes. We'll also be creating in that project, this SIG, examples of instances for each of the templates to make it easier to understand. The IIP project is concerned with information patterns, and they are looking at the requirements for common patterns that exist in many different places and defining a template information pattern, which is essentially an arrangement of templates that can be used over and over again. So this is providing a higher level of abstraction for the Part 7 templates. And if for those of you who have gone into Part 7 templates, then they are fairly low level, very generic, and so do warrant further abstraction. The EDRC project is really looking at equipment in terms of how ISO 15926 can be used in the context of equipment and all of the information relating to that. There's very close collaboration with both Mimosa and PCA, again with the OGI project, and it is focused on the narrow information that is common to the pilot and the HEED project, using again the tips being developed in the IIP project. Results of that project will also be fed back to JORD and the standards committee from TC 184. SC4, which is WG3, under which ISO 15926 and indeed STEP would fall. The project information flow project, this again is looking at the flow of information along the life cycle, and has a specific focus on piping isometrics and how they are fit in, and the extension to the model that is required in order to support piping isometrics. These are the current members of the project, and we welcome new members, so contact either myself or Faith if you are interested in joining the project. It is very much a working project, so we do expect that you will have a good understanding of a specific side. Either it could be a specific part of the engineering requirement or the O&M requirement, or you have particular expertise in modeling for engineering, data modeling, and a good knowledge of XML, and for those of you who are very interested in RDF OWL and semantic web technologies. So what we are doing here is aligning the two methodologies to update the information model using the JORD methodology and leveraging the work of the other projects, whether they're ones that have completed or whether they are current projects out there today. We want to be able to ensure that they are going to be able to meet the requirements of business. So that is the result of this should enable companies to deploy and gain business benefit through using ISO 15926. And the coexistence between the deployment methods means that those companies who are currently using the XML version, this Proteus schema, that's with interfaces supplied by the various vendors, can do so knowing that as the scope of support using Part 8 increases, that the information that they're transferring is going to be the same. So that if one company is using the schema-based XML and another company is using the Part 8, then interoperability is can still be achieved without any major work. So then the part there is that documenting the methods and mapping between them is what will enable that coexistence, and all of those classes will be available in the PCA RDS, so they are globally available to anyone, anywhere in the world. Well, okay, I think that was a bit of tautology, but there you go. So that, in a nutshell, is what this project is about. Progressing the deployment of 15926. It is in use today using XML, and it will continue to be of increased business value through increasing the scope from the model that was developed in the Proteus schema to that that's being evolved, and the methodology for deployment is going to be your choice, whether you want to use the XML version or whether you want to move on to Part 8. The two will contain the same information. Again, those interested in joining the project, please either email myself or Faith. And I think Faith, I should have left enough time for some questions now.
You did masterfully, Adrian. Thank you very much. And so thank you for your questions. I lost one of them, so Brian, if you could send your question again. Somehow I clicked in it and lost it. And if anybody else has any questions, please send them in. So one question, Adrian, is on the schedule. Can you maybe give us an idea of schedule and some of the specific current progress that you've made so far on the project?
Okay. Well, as I did indicate, we have now got to the stage where we're in collaboration with the Geometry SIG. We've now been posting into the sandbox the definitions for the 2D graphical objects and some of the additional classes that were identified as being required. They're also in the sandbox.
Everything just went dead.
Hello,
Hello?
Faith. Can you hear me, Faith?
Yeah, what happened, Adrian? We lost you.
I don't know. I just switched to telephone and back to mic and speakers, and it seemed to cure it.
Oh, okay. Well, thanks.
How much of that last?
I think we lost most of it. But we've got
Okay.
some other
Well,
questions too. But so go ahead.
very briefly then, we have achieved a lot. We have actually been running prior to getting the official launch of the project. We've been running for about 6 months, and so quite a lot of definition has been done. We have an engineering-based document that talks about the models for PNID, and one that is being developed now that defines some of the templates, which is again in a fair state. We have published some of the template definitions. The additional classes have been posted into the sandbox of the PCA RDS, and the schema, the updated schema, should be available in a couple of months. And whilst we don't actually have a formal end date, it's a little bit fluid, but we would certainly hope to have a very good definition for presentation at the April conference, and we'll give an update, obviously, at the fall conference.
Okay, great. So a couple more questions, Adrian. What is the relationship with this and Revit?
Well, Autodesk are involved in the Dexby project, and they have also joined the IIMM project. So that, I believe, is one that should be more focused at Autodesk as to which of their systems they plan to do. But just to say, whilst it's not in the remit of this project, there are other Element 9 activities which we have not yet been formally, well, they were formally proposed, but there's a project hasn't been started yet, which is looking at the interoperability between IFC or BIM and ISO 15926, and so that is probably more the scope of that, because Revit, I believe, is more focused on the AEC side.
Right, exactly. And we should say, too, we've got, in FIATEC, we have the Structural Steel Interoperability Project, which is looking at the BIM IFCs and some of the 15926 aspects. Okay, thank you, Adrian. So here's another question. If we create Proteus PNID output, can it be consumed by SmartPlant and or Bentley OpenPlant?
A leading question. The answer to that is actually yes, but it's not necessarily a vendor's own product in terms of Intergraph. As for Bentley, then I believe that, well, I know that there is a project that is actually doing that. How much that that development is going to be made public is a question that you would need to put to Bentley.
Okay, great. And then somebody did have a question about whether the presentation is going to be available on the FIATech site and when. And yes, this recording will be available on the FIATech site. It'll take us probably, sometimes we can get it up the next day, but usually it takes 2 or 3 days. And this recording will be available.
Self-destruct in 5 minutes?
Possibly. Okay, here's another question. It seems there are different projects working on 2D and 3D models, which are, however, for different industries. Do you see a big difference among them?
Well, if we focus on process plants, then process plants has a very small subset of geometry required for 3D, and that is what this project is focused on, and the geometry SIG for process plant. If you're talking about, and that's similar for AEC, although AEC does have some additional requirements in there, but it is very different to mechanical. So mechanical is mainly on BREP information, whereas in process plant there's very little BREP. It is mainly CSG primitives such as cones, blocks, and cylinders.
And we should say, probably just to reemphasize too, the different industries should be able to use the same information model, which is the goal.
Yes, I mean, as I stressed earlier, the PNID and the 3D model is the same, and the whole objective of 15926 is that irrespective of the source of the information, then the model that is created as the 15926 information should be the same, must be the same, because that's what the model says it should be. And so then you can use that information downstream without having to know what the source system was. That's the whole point of this. And as far as geometry is concerned specifically, then ISO 15926 Part 3, which is the geometry, is derived directly from ISO 10303 Part 42, which is the geometry for STEP. That is also the geometry that is used for IFC, where they use Part 21, Part 28 of STEP. And so the form of geometry that's used for STEP, for mechanical systems, for IFCs, for AEC systems, and 15926 for process plant systems is all the same base. So they're all highly interoperable.
Thank you, Adrian. Good point. Another question, what kind of contribution is expected from new members for this project?
I think, as I tried to outline, we're looking for people with expertise in a particular area. So that can be engineering. So you can say, have you thought about this particular part? And as our primary focus is on PNID and then moving to 3D, although the 3D will kick off as separate independent meetings. So it can be the engineering side, it can be those who have expertise in data modeling, those who have expertise in deployment of the semantic web. So specific areas there, and a good mix from all of those is what we need in the project. But I think one of the other areas that we should be thinking about in terms of working with 15926, the key is this flexible data model. So there is nothing hard and fast. So you should be open-minded in order to look at these things. But that in a nutshell is all we really need.
Okay, and I think the last question will be, how do you look at this IIMM project as compared to some of the new implementations coming out, like Ariva's AIR implementation?
Yeah. Well, they're all using, so Air is actually using the Proteus schema and their own deployment of technology to map from the schema directly to create template definitions, and then to use part 8 as the transport from that. So it's all very related, and again, so what they have learned in that project will be very useful, and they are planning, I think Jim Noumenon is planning to join the IIMM project so that we can gain from the experience and the value that they have got out of that project. So really any project that is using ISO 15926 in any form is a very useful project, and if we're not aware of any, if anybody knows projects that are on that basis, then we'd be very interested to talk to them.
Okay, I think we have time for one more question. We can squeeze it in, and this looks like it's our last one actually, so it works out well. Given the large volume of data it takes to define the geometry of a complex facility, how much effort is being applied to using parametric definitions?
Well, there are two answers to that. Firstly, the formal part of ISO 15926 has not, or in any of the projects, have not been looking at parametrics so far. However, the definition in part 3 will allow parametrics. It will allow expressions for the values for the attributes of the geometry. So in the Proteus schema does actually have parametric components and parametric geometry defined, and they have been used on projects with Smart Plant 3D, for example, and other projects will be expanding on those. So yes, parametrics, and if there's anybody, and certainly the person who asked that question, if they have a specific interest in parametrics, then I'd be very interested to talk to them. That is an area that has not really been touched by in great detail in 15926 to date. It's not in the current scope of the IIMM, I should say, but it could be, it would be a very useful scope for a different project.
Thank you, everybody, and thank you, Adrian. We've come to the conclusion of our hour, and thank you for spending it with us. And please be reminded that we will have a recording available on the FIATech website within the next couple days. And I hope you can join us for future FIATech Tuesday webinars. Please contact me or anyone at FIATech if you would like to do a webinar, if you have an idea for a future webinar. And everyone have a great day. Thank you very much. Thank you, Adrian.
Thanks.
Bye-bye.
Bye, guys.